Hello all, welcome to my course on methods of adhesion measurement, theory and practice. We are at lecture 39 today and we are going to discuss about adhesion of an adhesive between two plates, to sandwich between two plates. So, here is the geometry that we introduced in the last lecture. So, in a sense we have got this adhesive film which is sandwiched between these two rigid plates over here, and we will discuss about the case in which there is slippage and also in absence of slippage, and with adhesion and without adhesion. So, let us go into detail of that. So, let us recapitulate the stress equilibrium relations in plane strain approximation. So, we will discuss plane strain because here we have this plate, length of the plate from minus L by 2 to plus L by 2, and this is this width, and this goes to y axis, this goes to infinity. Okay. So, the plane strain will be along the y axis, it is very large in the y direction. So, essentially we will be dealing with this thickness coordinate h, and with this, so this is thickness coordinate, this is let us say z and this is let us say x. So, in essence this let me draw it properly. So, in essence what we have is here, this is the x axis and this is the z axis, this is the x axis and this is the z axis. So, z is equal to 0, okay, defines this particular surface, z is equal to 0 and this particular surface z is equal to h, that is the way it is. So, now this is an elastic film, and so we will like to write that the stress equilibrium relations, okay, in this film. So, in terms of the gradients in the strain. So, remember that we had derived earlier that the stress equilibrium relations can be written as del xx by del x plus del xy, and in this case del xz, because we are in plane strain approximation, and there is no body force there and this is at equilibrium. So, it is 0, there is no unbalanced force. So, the balance of force is there. So, there is no acceleration. So, this is 0. Similarly, for the z axis we have del zx by del x plus del zz by del z, this is equal to 0. So, these are the stress equilibrium relations that I had written earlier, I think lecture 2 or lecture 3, where we had derived this. But now I would like to write it in terms of the strain gradients, and so the xx, xz and all these things have to be written in terms of gradient, and that is what we will see. Those results are already there. So, we will just make use of those results, okay, that is all we will do, and then we will find out. Let us see. So, here xx is given as lambda into delta. So, we derived it long time back, and this exx, as you know, del u, this is del u by del x, and del ezz is del w by del z, like this. So, del xx, so here del xx by del x, okay, so that will be equal to E sigma by 1 plus sigma into 1 minus 2 sigma, and then we have to derive it with respect to x. So, it is del square u by del x square plus del square w by del x del z, okay, plus this is E over 1 plus sigma into, it will be del square u by del x square. So, here let us take this terms of del square u by del x square together. So, E over 1 plus sigma into del square u by del x square into, this is 1 by 1 minus 2 sigma plus 1 by 1 plus sigma here, plus it is E sigma by 1 plus sigma into 1 minus 2 sigma into, this is del square w by del x del z. Now, this is equal to, this is E by 1 plus sigma into del square u by del x square, and here it is 1 plus sigma into 1 minus 2 sigma. So, it is 2 minus sigma by 1 plus sigma into 1 minus 2 sigma. Yeah, I think it's like that. Plus it is this quantity E sigma by 1 plus sigma into 1 minus 2 sigma into del square W by del x del z. Oh, I see. So there is a sigma here which I had missed. There should be a sigma here. Sigma by 1 plus sigma by 1 minus 2 sigma, and this is E by 1 plus sigma. So it is sigma by 1 minus 2 sigma. So here finally it comes out to be E sigma into 1 minus, it is 1 plus sigma 1 minus 2 sigma, so 1 minus sigma. So it is sigma here. So it will come out to be 1 minus sigma. Why I am getting 1 minus 2 sigma here? So this is E by 1 plus sigma. So therefore there is no other 1 minus sigma here. So it is sigma minus, this is sigma minus 1 minus 2 sigma. So it is 1 minus sigma here. This is 1 minus sigma here. So it is E into, therefore it is E into 1 minus sigma divided by 1 plus sigma into 1 minus 2 sigma into, this is del square u by del x square plus this is E sigma by 1 plus sigma into 1 minus 2 sigma into del square w by del x del z. Good. So I have gotten it. So now this I have obtained. So now zz similarly over here can be written as, this will be E into 1 minus sigma by 1 plus sigma into 1 minus 2 sigma. Instead of del u by del x, you see we will have del w by del z, okay, because x and z and x and z in one hand and u and w on the other hand, they are equivalent. So this is okay. So this is E over sigma by 1 plus sigma by 1 minus 2 sigma, and this is will be del u by del x, right. And so therefore del zz by del z, so that will be written as E into 1 minus sigma by 1 plus sigma into 1 minus 2 sigma over here, and here it will be del square w by del z square plus this is E sigma by 1 plus sigma by 1 minus 2 sigma, and this is del square u by del x del z. And we have to have xz also. So xz zx, so it will be let us say del xz by del z, del xz by del z, that will be E by 2 into 1 plus sigma here del xz by del z, del xz by del z. So actually we should say del xz by del x, del xz by del x, yeah, del xz by del x, let us first calculate. So it will be del square w by del x square plus del square u by del x del z. And if I want to calculate, let us say del zx by del x, del zx by del z, del zx by del z, del zx by del x, or xz by del z. So del xz by del xz by del z I should have. So let us do like this, let us correct it like this, del zx, and let us do it like this, del xz by del z, same thing, no issues. So this will be equal to E by 2 into 1 plus sigma, and here it will be by del z. So it is del square w by del z square, del z del x, del z del x plus del square u by del z square, okay, like that. So yeah, we have all this. So I have already estimated, this is all estimated. Now del xx by del x plus del xz by del z, that I have to write. So I have already written here. So this is after we accumulate all the terms we just derived. So here we write it, we can simplify this expression, and we need to do that. So here for example, it is E into 1 minus sigma by 1 plus sigma into 1 minus 2 sigma. This is del square u by del x, sorry about that, del x square plus. This is E by 2 into 1 plus sigma into del square u by del z square plus I have got the del square w by del x del z term. So, I will write it over here E sigma by 1 plus sigma into actually let me add it up, no, let us find 1 minus 2 sigma plus E by 2 into 1 plus sigma del square w by del x del z, that is equal to 0. So, let us algebra, that is it, little bit, not all that difficult. Now, we put together all the terms. So, let us say it is E into 1 minus sigma by 1 plus sigma into 1 minus 2 sigma. Let us take it outside, let us take E over. So, then it is 1 minus sigma here into del square u by del x square and then plus. So, here I have taken, so it should be 1 minus 2, no, it is I have taken 1 minus 2 sigma. So, it should be 1 minus 2 sigma by 2, because I have taken E by 2 into 1 E by 1 plus sigma outside. This should be yeah, like this, that is fine. This is del square u by del z square and then plus. So, I have taken E by 1 plus 1 minus. So, it is actually, so therefore, this is let us say sigma plus E plus 1 minus 1. So, it is sigma plus, this is actually 2 here and this is 1 minus 2 sigma by 2 del square w by del x del z del square w is equal to 0, bracket here. So, here E by 1 plus 1 minus sigma, so sigma here and E by 2 into 1 plus sigma. So, 2 should be anywhere there and 1 minus 2 sigma here, right. So, therefore, this quantity, so see this I can get rid of. So, what I will have is here, from here I will have only 1 by 2. So, I will just multiply it by 2 here. So, I will have 2 into 1 minus sigma del square u by del x square plus 1 minus 2 sigma del square u by del z square plus I will have del square w by del x del z, this is equal to 0. So, I have quite a bit of simplified my stress equilibrium relation in terms of the deformations and deformation gradients. So, yeah, this is what I derived over here, I have it. Now, the other equation, so will be, so from here I can read directly 2 into 1 minus sigma, instead of u I will have w here, instead of x I will have z here, plus it is 1 minus 2 sigma, and then I have instead of u I will have w here, instead of z I will have x here, plus instead of w I will have u here, and here it is del x del z, that is equal to 0. I can directly write it, right. So, I have therefore, these two equations, stress equilibrium relations, and I will also have this compressibility relation. So, that is actually del u by del z plus del w by del x, right. So, that is equal to minus of P is the hydrostatic pressure divided by K, K is the bulk modulus here. Okay. So, do not confuse with this K with the K that I derived in the earlier lecture 4 E star by 3, no, it is not that, it is actually the bulk modulus here, right, it is the bulk modulus. Please be careful about that. So, this is what I get. So, these are the two stress equilibrium relation, and then this is the bulk modulus, and this is the compressibility relation in the or volume strain. I have written it already, is like that. So, the problem that we will address now is this, that the compressor, these are the basic equations, and that will anyway be valid for all the problems. So, now I am solving the, I am now defining the problem means I am actually talking about the boundary conditions, okay, that is all it means. So, the compression of an elastic film sandwiched between two parallel plates means like I am applying some compressive load here. The film remains bonded to the bottom plate. So, the bonded in the bottom plate means that there is no deformation at z is equal to 0 either in the horizontal direction, x direction or in the vertical direction, like that. No slip boundary condition holds at the interface of the film and the top plate. So, what it means is that at this plate, that means at z is equal to h, okay, no slip boundary condition. So, no slip means that u will be equal to 0 because this plate is being just compressed. So, the plate is not being given any horizontal deformation, no horizontal displacement, no. So, as a result u at this place location u is equal to 0 because of this no slip condition, right. And on the other hand, for w will be the vertical displacement. So, the w, okay, at this j is equal to h will be the vertical displacement, and I think I have represented by delta here, we will come to that. So, I think I should write minus delta, but I will come to that, we will see what exactly I have written there. So, this is the way this problem is defined and we will like to solve it. Now, how to go about that? There are actually partial differential equations, okay, which cannot be solved analytically unless we make some reasonable approximations. So, this reasonable approximations will be done, we can do it if we can write these equations in dimensionless form, in the sense that we can then find out that the which terms here are important or which are not, and the ones that we are not or very much less with respect to the other terms, okay, they can be neglected without incorporating much error in the calculation, that is the idea. So, what do we do? How do we do this characterize the non-dimensionalization? Now, that we will do by writing this every term in terms of their characteristic quantities. So, for example, that the characteristic length, okay, along x axis will be capital L, and u is also deformation, that is also therefore, u will also characteristic length for u, the displacement or deformation along the x axis will also be characteristic length is capital L. So, capital U is equal to u by L and capital X is equal to x by L, because capital L is the characteristic length along the x axis. Then the h, so h is the characteristic length along the z axis. So, therefore, this deformation along the z axis will be represented by w by h, that is capital W is equal to w by h, and here capital Z is z by h. Now, you note that in this case the film is thin, and very thin in the sense that h, okay, is much smaller than L. So, that condition holds. So, whatever we are going to say now, okay, is in that limit. So, let us write down this u, w, x, z in terms of this dimensionless quantities, and remember that when you do that, okay, we can actually do that easily. Let us try to do that over here, and then I will go to, because let us derive it. So, it will be 1 minus 2 sigma, and this is u, so it is L, and this is z here, so it is h square, this is del square capital U by del capital Z square, plus this is del square W, so it is h here by, it is x is L, z is h, and this is del square capital W by del x del z, plus 2 into 1 minus sigma, this is u is L and this is L square del square u by del L square. So, this is equal to 0. So, here this h gets cancelled, here L is L, this L this gets multiplied. So, I will have here therefore 1 minus 2 sigma into L square by h square del square u by del x del z square, plus here it is del square w by del x del z, plus 2 into 1 minus sigma, this is del square u by del L square, this is equal to 0, that I have. So, this is for this equation. Now, for the other equation I will write on the other side. So, here this is 1 minus 2 sigma, and this is del square W. So, this is H here by L square, this is del square capital W by del x square capital X square plus this is X, this is L, this is L, this is L, this is H, right. So, for U capital L here and X capital L and this is Z, this is H and it is del square capital U by del X del Z plus 2 into 1 minus sigma into for W this is H and this is Z square. So, this is H square and this is therefore del square capital W by del Z square and this is equal to 0. Here again this L gets cancelled, this H is over here. So, if I do it, so let me do it over here only. So, I will write it here therefore H square and let me get rid of this, let me get rid of this. So, I have this now. So, I have now this H square by L square into del square by del x square, del square U by del x z and del square W by del z square. So, this is the way I have here this dimensionless form. So, here notice as I have already said that H by L is much smaller than 1, much smaller than 1, and if you remember in fluid mechanics you had this kind of situation when you solve the boundary layer problem, where to you use what is known as this lubrication approximation. So, this lubrication approximation suggests that H thickness of that film, liquid film or the fluid film used to be much smaller than the spatial the dimension L, and we can see here that this term therefore, H square by L square term is very small. So, this term can be neglected. So, after neglecting what we have is only this term here and this term here. So, that is the way we have it. Now, here we can do one exercise, we can actually integrate with respect to z and what we will have therefore is del W by del Z. So, let us say that it is del U by del X, del U by del X plus 2 into 1 minus sigma and del W by del Z. Okay. So, this has to be some constant with respect to Z with respect to X, because then only after derivation with respect to Z this will be equal to 0. So, we can actually do this. So, del U by del X plus 2 into 1 minus sigma, okay, after integration. So, I have integrated this quantity. So, this is the integration and I have gotten that and I have written it to be Ax. So, yeah, so it will let us say minus x here. So, it is Ax equal to 0. So far so good. Now, I can do one thing, I can derive it with respect to x. So, derive it with respect to x, it will be 1 by 2 into 1 minus sigma, it is del square u by del x square plus this is del square w by del x del z plus this is del of a of x by del of x, this is equal to 0. So, yeah. So, now what I can do is that I am going to write down this expression into this expression over here, that is what I am going to do. So, here differentiating with respect to x, I got this and then substituting in here. So, let us substitute. So, it is 1 minus 2 sigma and there was L square, let us write L properly. So, L square by h square and del square u by del z square plus, now this is plus, now I am right, let us write minus only. So, the minus 1 by 2 into 1 minus sigma, this will be del square u by del x square and minus this is del of a of x by del x, then plus this is 2 into 1 minus sigma into del square u by del x square, this is equal to 0. So, let us now accumulate all the terms together. So, it is 1 minus 2 sigma into L square by h square into del square u by del z square, and then I can do the following. Let us do this. This is 2 into 1 minus sigma. So, it is 2 into 1 minus sigma here and then minus this is 1 by 2 into 1 minus sigma here into sorry about that, del square u by del x square and minus del of a of x by del of x is equal to 0. So, this quantity. So, now let us get this. So, it is this term comes out to be 2 into 1 minus sigma. So, it is 4 into 1 minus sigma square minus 1. So, here it will be equal to 4 minus 1, this is 3, minus this is 1 minus 2 sigma. So, minus 8 sigma. So, 2 is fine, right? I did not miss anything, I hope. Okay, no, that is fine, I guess. So, it is 3, it is 3 1 minus 2 sigma. So, it is 8 sigma 4 sigma square. So, I guess there is a easier way to write it. I will see what I wrote it in earlier, 1 minus sigma, but I can write it in a more compact form. I can do it in a more compact form. Let us do it that way. So, here let us do it like. So, it is let us say it is 2 into 1 minus sigma whole square minus 1 square. So, it is a square minus b square. So, a plus b into a minus b, let us write it like that. So, a plus b, so it is 2 into 1 minus sigma plus 1. So, it is 3 minus 2 sigma, okay, and this is 3, this is 2 minus 1. So, it is 1 minus 2 sigma, like that. Yeah, I think it is good, okay, into. So, this is this quantity over here, into we have del square u by del x square and minus this. So, I have finally this quantity that I have already derived. Epsilon square is also coming. So, epsilon square has been is here. So, I multiplied epsilon square both the sides. So, epsilon square here. Now, what happens is this quantity. Now, you see here that this is 1 minus 2 sigma into 3 minus 2 sigma into 2 1 minus sigma here and with an epsilon square here. So, this term of course, we do not know anything about. This term we do not have an epsilon square, here we have an epsilon square and we have further this term. So, this term is expected to be too small. So, we can neglect this. So, therefore, we will have that 1 minus 2 sigma into del square u by del z square minus epsilon square into del square, this is a of x by del x, okay, is equal to 0. That will be the equation that will be there. So, smaller than other terms. So, we have it. So, let us now integrate this equation and we will get like this, u is equal to, it will be let us say epsilon square by 1 minus 2 sigma and this is let us say z square by 2, this is let us say del of double integration that we are doing del x plus, okay, this is z into b of x plus cx, right, because we are integrating double integration we are doing. So, it is like that. So, epsilon square by 1 minus 2 sigma into del a by del x z square by 2 plus z into b of x plus cx, and now we have to apply the boundary conditions to see that what are the values of this integration constants. Remember that since I have integrated it with respect to z, that is why this integration constants bx and cx, these are function of x. So, I will stop here today and I will take up further, okay, in the next lecture. Thank you.